changes in Ukraine, integrating satellite data and land cover analysis. It's also related to warrant changes in the country. Anna, please.
Can you hear me?
Yeah, everything is good.
Good. So hello everyone, dear participants of the conference. My name is Hanna Ilimova, and I would like to present to you our research about assessment of methane concentration changes in Ukraine, integrating satellite data and land cover analysis. This research was done by our team from the National Technical University of Ukraine, Kiev Polytechnic Institute, Space Research Institute of Ukraine, and University of Maryland. So let's start this short content of my speech, and let's go to the motivation and research justification. As you know, methane is a potent greenhouse gas, and its role is in climate change mitigation is very important. It has a much higher heat trapping capacity than carbon dioxide. Also, it stays in the atmosphere for a shorter period. Agriculture is a significant source of methane emissions in Ukraine, especially due to the vast land cover dedicated to crop production. And therefore, effective land management practices are key to controlling methane emission. And the study aims to assess methane concentration over Ukraine with satellite data to identify vulnerable areas and improve or give some or improve land management strategies. There are primary sources of methane monitoring. It is ground measurement, drones, and satellite monitoring. Ground measurements such as Global Monitoring Division of NOAA and ICOS and gauge systems provide highly detailed local data, but they are not available for Ukraine, and they lack comprehensive spatial coverage. Drones offer target measurements, but are source intensive for large area. And satellite monitoring for broader spatial and temporal coverage, making it the ideal choice for monitoring large regions such as Ukraine, for example. And we have analyzed different satellite sources of methane measurement, and for our study, we selected Sentinel-5P because within publicly available products, it has a higher spatial resolution than another products. As you can see it from this table. This research, as I said, used satellite data from the Sentinel-5P satellite. We use it in Google Earth Engine. You can see here the collections that we use. And this data covers methane concentration from 2019 till 2024. And additionally, we used land cover classification maps for the same period. These maps developed by our team within World Bank support and include since 2022, after the Russian invasion in Ukraine, new class such as abandoned cropland. Here is highlighted by black color on the image. This slide shows a spatial distribution of methane concentration across Ukraine, visualized using Sentinel 5P data. And as you can see, there are regional variations in methane levels. Higher concentration are generally observed in areas with intensive agricultural activity, while war-affected regions tend to have lower concentration. This spatial analysis helps us identify a specific area where target methane reduction effort could be most effective. And really, as you see on these two pictures, photos 2023 and 2024, you can see that along the front line, the concentration of methane is lower than for another territories of Ukraine. So let's look at the results. Our analysis reveals a steady increase in methane concentration across agricultural regions in Ukraine since 2019 till 2024. And on average, methane concentration rose by over 2% during this period. And this trend emphasizes the growing concern of greenhouse gas emissions in the agricultural sector and their impact on climate change and people's life in general. And another key finding in the comparison of methane concentration between active cropland and abandoned land in 2023, for example, we observed that methane concentrations were significantly lower over abandoned lands, particularly in the regions most affected by military activity, such as Zaporizhia, Donetsk, Luhansk, and Kharkiv. Because in this, for this territory, we have more abandoned area. And this suggests that land use changes influenced by ongoing war have a noticeable impact on methane emissions. And the left part of the slide also show a clear relationship between the cultivated area in Ukraine region and the methane concentration. I did not show it on the slide, but the Pearson correlation for these two value is 0.72, and as you can see, the coefficient of determination is 0.53. And in conclusion, our research has demonstrated a clear increase in methane concentration over Ukraine between 2019 and 2024, with a strong correlation between methane levels and the extent of agricultural land. And the average annual methane level increased by over 2% during this no long period. Significant regional variation were observed, with northern and central areas showing more growth than the southern regions affected by military activities. And I can say that satellite data such as Sentinel-5P, for example, has proven useful for monitoring methane, especially in regions where ground-based measurements are not available or are limited. Also, we would like to acknowledge the National Research Foundation of Ukraine for supporting this research under the project, and thank you for your attention. I can answer your question if you have.
Of course, we have a lot of questions. We like your presentation. Colleagues, questions to Hannah? I have maybe the question, is it enough special resolution of Sentinel-5P for this task? So,
I think that enough, but we have no better right now, so we need to use what we have. But satellite data provides the possibility to use to analyze the methane concentration for large areas. So we cannot to measure a lot of to put a lot of ground station and to measure from them. So we need some global.
okay, and how frequently the methane concentration is changing?
From Sentinel-5P or what? What is revisit time, you ask? Maybe. No?
Not revisit time. How often should we have observation of methane on the base of Sentinel-5?
I think it's an open question. In this research, we do it one time per year is average composites from this data. But I think we can do it monthly or weekly or how we can, how we need. But we should remember that Sentinel-5P it's optical satellites, and we have the problem with clouds for it. So we need to remember about it.
Yeah, thank you. Maybe one more questions from somebody. Okay, no more question, and thank you very much. The next presentation will be done by Sophia, but I should mention that Sophia now